to all session chairs, session co-chairs, and professors and fellow researchers. I'm Prabhat Kumar from Nepal Engineering College, and today I'm going to talk about my project research on an efficient deep learning-based mobile application for presently disease classification. So to start this project, what were the motivation? What was the introductions that we have followed to start this off? So agriculture supports about 65% of Nepal's population, and we use a lot of legume crops, and among them peasant pea is one of the legume crops that we use. And in Nepal, mainly these legume crops are sorted by yield loss for about 40%. And the only way farmers rely on to reduce this is manual visual inspection, which is slow, subjective, and most of the time inaccurate. So what they need to solve this problem is an accessible, accurate, and real-time disease detection solution, what we have tried to propose. So what are the problems that primarily we found? The frequently peasant pea disease outbreaks drastically reduce productivity of peasant pea, and the agronomist accessibility in Nepal is very limited. Public availability of Nepal-specific peasant pea data set are almost non-existent, and existing solutions mainly depend upon cloud and web-based platforms. And the system that seems to be lacking most of the time is lack of mobile-based disease diagnosis system. So these are the two objectives that we have niched down to. So our main objectives are to develop and validate a deep learning multi-class disease detection model capable of accurate real-world disease identification using Nepal-specific field-collected peasant pea leaf image dataset, and then to deploy and evaluate the optimized model on mobile platform for real-time offline peasant pea disease detection, ensuring practical usability under resource-constrained conditions. So these are the literature review for which we have considered about 20 to 21 reference papers. And this is the example of image dataset that we have tried to classify by the help of experts and agronomists across mostly by the help of our professor, mainly Professor Videsh Prakash Goraga and Professor Vijay Shrestha. And this is the major works with notable outcomes that has been done in this way. And this is now let's talk about the methodology part. So first of all, we did data acquisition. For that, we have collected peasant pea data sets from local farms, mainly from Chitwani area, and then we tried, classified those data with the help of agronomists under the guidance of our professors, and then we have trained machine learning models, and then deployed on mobile application, which we have developed using Java in Android. So in total, we collected 7,930 images across 8 classes, which consists of 7 diseases and 1 healthy class. So the data pre-processing processes went through labeling, augmentation, and normalization, and we use transfer learning using fine-grained visualization model, and for mobile deployment we use TensorFlow Lite optimization. So this is the ratio by which we divided the data. This is 80% for training and 25% for validation, which sums up to a total of 7,933 images. These are the hyperparameters we used for fine-tuning the disease selection model. These are the results we achieved through our process. So the overall classification accuracy was achieved to be 98%, and F1 score, high precision recall and F1 scores across all classes. Training and validation conversions were achieved, and K-flag model was used, which reduced the size of the model even more, and the average inference time was also suitable for real-time disease detection in farms. So this is the result across which says that accuracy is 98%. across all classes. And this is the chart of mobile activity and loss, which seems to be consistent across all diseases. And this is the confusion matrix. Now, in this confusion matrix, few diseases are not that much prioritized because we were not able to collect data sets across all diseases equally. So, except for Fusarium Whip, right, other diseases which seems to be fine for real world application. And this is the mobile application we developed, wherein you have to log in once, first of all register once, and then you can log in and then select on the present disease card, and then you will have to click on the camera option. The camera opens, you focus on the infected area of the leaf, and you click OK, and then it shows what disease the leaf is actually infected by. And to conclude, we have achieved 98% of the accuracy, and we have achieved mobile-based, offline and farmer-friendly solution, because everyone now has mobile devices, as talked by our professor during the plenary talks. I think 116% of mobile penetration, so everyone has a mobile phone, and it is validated on real-world Nepal-specific data set, and it does demonstrate feasibility of AI in agriculture. And future work includes, we are still in the process of collecting data, so expansion of data sets across even more regions will be done, and we can integrate how severe the disease is in a particular leaf, and we can also explore a lot of even lighter deep learning models than VGT16, and also add multilingual and advisory features for farmers. And these are the references that it considers if I am more in detail.